All right, here we are. We've got a fairly difficult problem here where they're asking us to condense. What does condense mean? It just means make everything smaller. At the end of the day, we'd like everything to just be written as one logarithm, kind of like this. Log, probably base A of some stuff in here. We're not sure what's going to be in there, but that's the goal. So how are we going to go about it? Well, let's not panic. Let's first take a quick look at our properties. So we've got the product property, which says when there's a multiplication inside the logarithm, it changes into an addition on the outside. We've got quotient property, which is where we've got a quotient on the inside becomes subtraction on the outside. And we've also got the power property, where if we have a number multiplied by a logarithm, it's the same thing as having an exponent inside the argument of the logarithm. So with these three properties, we can do a lot. Okay, let's give it a try. So first of all, we see the same base here on these two logarithms in the very beginning. So let's just combine that. We have a plus sign in between two logs, so that can become a multiplication on the inside. So let's see here. So we've got log base A, and then on the inside, we're going to multiply the two arguments. Well, here's one argument, and here's the other argument. We're going to multiply them. Okay, y times 2x minus 3 multiplied by y 5x minus 2. Okay, no problem. So that the first two logs, we've already condensed them a little bit into one log. Okay, let's keep moving here. The next one, let's just leave it alone for the time being. Log base A, y x minus 5. Okay, and this last one, check it out. We have here a number multiplied by a logarithm. Well, remember over here on our properties, we have this here. Basically, this is what we have. We have a number multiplied by a logarithm, so we're going to change that into an exponent on the argument. Let's try. Okay, so we're going to have here subtract log base A. Now what we want is, here's the argument, 3x plus 1, and we're going to move that 2 up into an exponent. Okay, good first step. Okay, let's keep moving here. Next step, let's go, okay, log base A. Now here we have the same base. We've got a base y and another base y, no problem. When we're multiplying powers with the same base, we can add the exponents. So what we actually have is y to the 2x minus 3 plus 5x minus 2. Okay, that's all inside this logarithm. Good. Okay, then what? Well, let's see. Tell you what, let's take this negative sign out for now. That might be one way to approach it. So what we can do is just put big brackets here, and inside we've got log base A, y to the x minus 5, and now we've got a plus here because of this subtraction sign. So plus log base A. Now, let's think about this part here. This 2 and this, these are both, this is like power of a power rule. So we can actually multiply the 2 by the other exponent. So we have here y, 2 times 3x is 6x, 2 times 1 is 2. Okay, and that's all inside this big brackets. Okay, it's still looking a little scary, but we're getting there. Let's see, log base A, copy all this down. Oh, wait a sec. Now we got 2x here, and we got 5x here, so that's going to make 7x. Here we've got minus 3 and minus 2, so that's going to make minus 5. Okay, minus. Okay, inside this big brackets, we now have log base A here, log base A here, but we're adding. Okay, we're adding, so that means back to our properties. We have, this is the situation we have, so we're going to move it over into this situation. Okay, so that means we're going to take this thing, and we're going to change it into log base A, and we're going to multiply those two arguments. Y to the x minus 5 multiplied by y to the 6x plus 2. This is all inside the log. Okay, almost there. You can see it's condensing nicely. I guess we'll do it in 2 more steps. Let's see if we can squeeze this in. Log base A of y to the 7x minus 5 minus log base A of the, let's see, we're multiplying powers that have the same base, so then we can add the exponents. We have y. I'll try to do this in one step now. So I'm adding these two exponents, this one and this one. So x plus 6x, 7x. Negative 5 plus positive 2, negative 3. Okay, almost there, folks. All we've got is this one last subtraction sign right here. So then that's going to be the quotient law. So we're going to finally change this into another logarithm, just one log. That's what we wanted it in the first place. So that's good. Okay, so with this subtraction, is going to change it into a quotient. This will be the numerator, whoops, and this will be the denominator. Okay, so let's see. We have y 7x minus 5 over y 7x minus 3. Okay, look, we've condensed it down into a single log. Tell you what though, we can make it a little bit better because we have the same base y and base y. So I'm just going to squeeze over to here now. Let's make a little bit of a separate compartment here. Okay, no problem. So now we've got log base a, and because they have the same base, we can subtract the exponent. So it should be y to the power 7x minus 5 subtract, I'll put brackets here to be careful, 7x minus 5 subtract 7x minus 3. Okay, excellent. Now this is all the argument of the logarithm. Okay, last step then. Log base a, okay, y is inside the logarithm. 7x minus 7x, that's 0x. And negative 5 subtract negative 3. Be careful here. Negative 5 subtract negative 3. That makes negative 2. All right. That is very condensed. To be honest, if we really felt like it, we could even move that negative 2 exponent using the power law back down. So ultimately, we could write it this way. Negative 2 log of y. That's it. That's all she wrote. If you folks can understand all that, then the next step is to be able to do it by yourself. And once you can do it by yourself, then it's practice, practice, practice until you're an expert getting it right every single time. And there you go. Enjoy.